All right, let's do some Mathity-Math. It says write the equation that shows the top line is the same length as the bottom line. When presenting your final answer, combine all like terms. Then solve for the variable. Okay, so there's a couple parts to this. Let's take it step by step. First things first, it says show the top line is the same length as the bottom line. Okay, so that's just another way of saying equal. Show that the top is equal to the bottom. And visually, we can confirm that. Right, they're the same, but this might not be drawn to scale or something like that. So let's go ahead and prove this mathematically. So for the first part, let's just tackle the top line. And it did say that they want us to combine all like terms. So let's just start there. So I'm going to go ahead and highlight the terms with the variable x. There's this one, there's this one, and this one. Okay, so those all have a variable x, and I need to combine those. So combine those is just adding. So I just say 12x plus 6x plus 7x. In other words, 12 plus 6 plus 7. Well, 12 plus 6 is 18, and 18 plus 7 is 25. So the first thing I would write is 25x. I'll just write it right over here. 25x. Good. Now let's take a look at the constants. The constants are the terms without variables. There's a 3 and there's an 18. And you see how I represented these with different colors and shapes? It's just so I don't mix them up. And I really wanted to visually show here that these are like terms, the pink ones, and these are like terms, the ones with the circles. Those are the ones that can add and subtract. So because these are all stacking together, it's like adding. So we say 3 plus 18. 3 plus 18 is 21. Okie dokie. Now because they are equal, I just make an equal sign. No problem there. And now we're going to come down to the bottom. And so looking at this bottom line, I am going to take a minute and go ahead and, again, highlight my terms with a variable x. So I can really clearly see, which terms have a variable and which terms are constants or non-variables. Okay, so there we go. So we can see my terms with variables. And I have 3x, 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 9x, and 5x. We want to add all those together because, again, they're kind of stacking together. And if these numbers are getting, a little scary or there's too many and you're worried you're going to make a mistake, I always encourage you guys, bust out that old calculator. Right? Let's take a look-see here. So we have 3 plus 3 plus 3 plus 3. Coming over here, I have plus 9 and plus 5. 26, great. So we can see here that these over here are 26x. And now we're going to take a look at our constants. I have 1, 2, 3, and 1. We can add these up. 1 plus 2 is 3, 3 plus 3 is 6, and 6 plus 1 is 7. All right. And that actually is the first part of the question. We're showing that the top equation, that's this right here, is the same as the top picture is the same as the bottom picture right here. And this is the equation. So I'm going to take a minute. I'm going to box that off because that's a good answer. And I am proud of that. So let's show it off with a beautiful little frame. Okay. For the next part, it says we want to solve for the variable. So to solve for the variable, we just do some basic algebraic manipulation. I'm going to rewrite this so I can clearly show what I'm doing and not mess up my first answer. Okay, so we want to move the variables to one side and the constants to the other. We do that with basic algebra. So I have a positive 26x. I want to get that over here. So to move that, I subtract both sides by 26x. This is just kind of the idea of balancing our equation. If I do it to one side, I have to do it to the other. And in general, you can do whatever you want as long as you do it to each side equally. Keep it even Steven, or fair and square. So these will cancel. 26 minus 26 is 0. And 25x minus 26x is actually negative 1x. Okay. Coming over here, I want to get this constant over here. So I'm going to subtract 21 from both sides, and the equal sign can come down. But 21 minus 21, well, that goes away. And we have 7 minus 21. 7 minus 21 is negative 14. And we're very, very close to being finished here. We just have to get this x all by itself. Now, right now, this x is being multiplied by negative 1. Okay, so what's the opposite of multiplying by negative 1? Well, we just divide by negative 1. And again, working with that idea of balancing our equation, we just divide both sides by negative 1. And what we're going to get here is these will cancel again, and we get x is a positive 14. Remember, it's a positive 14 because if you multiply two negatives or divide two negatives, they are, in fact, positive. Now, before we frame up and box this answer, I do think it's important that we establish the habit of substituting in this x value back into our original equation we made just to check our work. And so remember, this says x is 14. That says wherever I see an x, I can stick in a 14. That is substitution. So if I rewrote this 25, but instead of x, I'm going to write times 14 plus 21 equals 26. And again, instead of x, I'm going to substitute in with a 14, so times 14 plus 7. And let's quickly check this work. And we can, again, just use our, let's get the angle right here. We can just use our calculator. 25 multiplied by 14 plus 21. That gives us 371. Oops. Okay, and 26, I'm right here. 26 times 14 plus 7, 371. All right, good news day. Take a look. It says here 371 is 371. Well, is 371 371? Yeah, it is. Those are, in fact, the same thing. We just proved it. Good job. So that means this 14 is the value of our variable. And we are done. As always, go ahead and subscribe if you want to be notified when I make more practice problems for you. And if there's any question type or a fun type of story you want me to write, just leave a comment below and I'll make sure to do that for you. Thanks. Bye.